Well, here we are, DCAC week. This is my DCAC Live is selfishly my favorite conference and my favorite part of the year because I get to bring in all kinds of incredible luminaries. We just walked in, we were listening to Wade Vincent of NVIDIA talking, and today's a day of some really strong powerhouse speakers, I think. But I'm really, really grateful that you came into town today. Why don't you introduce yourself and tell people who you are, where you're from, where you traveled in from, and let's chat, man. I'm excited to have this conversation.
My name is Tobias Quaranta. I'm a senior solution architect for Submer, immersion cooling company. We're headquartered out of Barcelona. I'm in Northern Virginia, so I'm in Loudoun County and Data Center Alley over there. And we're building up our U.S. team and opening up a new assembly and manufacturing facility in Houston.
Good place to put it.
Pretty wild. And this is my first time at this conference.
What do you think so far?
So far, so good. I mean, this has been pretty awesome. I'd like to get all the technologies that we've seen so far in one room and build the data center of the future and just see what that kind of looks like.
That's what I'm talking about. So talk to us a little bit about Submer. It's Submer?
Yeah. So think of submerge, but without the ERG.
Okay.
So we do immersion cooling. We essentially have two products. One is an Evo, which is, it's a tank. So it's a tank with a CDU, and we put servers in that tank. And, you know, just like your grandmother
buy the
said,
tank that come with the servers, or?
No. So we'll work with server manufacturers for that. It's still a little scary to some. So this is all new for some people.
Is this like a glycol, some sort of mineral oil? Dialectic immersion?
It is. So we make our own fluid, and then Shell makes a fluid, BP Castrol makes a fluid, ExxonMobil makes a fluid. So we're fluid agnostic. We essentially build the tank, and then we work with different vendors to make the immersion servers that go in there. So there's no fans on them. The heat sinks are a little bit wider, just because you don't have air. And the cooling capacity for them is a lot higher and a lot denser. So we're looking at servers that have maybe up to 8 GPU clusters on 2 RU worth of space. So very, very dense.
So let's start at the beginning. This is headquartered in Spain, this company?
Submer? Yeah, we're headquartered in Barcelona right now.
And how did you come to them?
So a friend of mine started working over there, and I worked with her over at Equinix, and she gave me a call. She said, come on over. I was over at General Dynamics at the time, and I jumped on over, and I've been there about 5 months, and it's been a wild ride so far.
And were you already in Northern Virginia?
I was already in Northern Virginia, yeah. So my background is, AT&T, WorldCom, XO Communications, and wound up at Equinix for a while, and General Dynamics, and now over to Submer.
So Submer has been around for a bit, and what was the genesis behind that product? Because, you know, you've explained to me the density capabilities that you guys had, and this is the exciting part. This is the data center gold rush of 2024, right? So for the next 3 years, people like us that are selling picks and X and shovels are going to really be able to introduce a lot of cool solutions for people to try into the industry until we figure out what works the best and what becomes part of the new standard, right? And right now there's just a flush of ideas hitting the market on the mechanical permutation. Where did that company start from? Were they doing Bitcoin miners first that were having the highest level of density per rack, and they're working backwards into AI now?
So we do have some customers that are doing Bitcoin, and they looked for that. And that's a particularly different build because that's an ASIC type of computer versus general. I think what we really were trying to do is get that operational efficiency. You know, how do we lower that PUE? What came out of that, though, is now all of a sudden you've got an AI and HPC gold rush. So the effectiveness of the cooling is so much better than what air cooling can do. Even with rear door heat exchangers, hot cold aisles, you're going from capacities of 5 to 6 kVA per cab, with direct to chip 70 kVA per cab. Some of our pods do 140 kVA per cab, and our largest one does 360. So I think it was originally just done out of efficiency, trying to get efficiency and go for like as green as we can for the tech.
But was there a client demand for it? Because, you know, sometimes people try to create the greatest product. Engineers will create the greatest, most economically. No, they won't. It'll make some nerds are so wrapped up into their technology that that's the only thing they think about. They're like, well, if the technology application itself is the solution, then why aren't we just going with it? And then someone that is in finance comes in and says, well, there's a reason, right? I mean, yes, you can make a tier 4, gold proof, bulletproof data center, but it'll be $25 million a megawatt type of thing, right? So you're like, just because you can doesn't mean that it pencils. Your product was designed for efficiency first. And what was it, client driven, or was it just someone there worked it somewhere else and said, hey, we're being asked to make this mechanical solution already. This is what we're giving to our clients. Now we need to adapt on it and iterate to a higher density level product. I mean, what was driving it? The capability of technology would make it to where you wouldn't productize it yet because technology continues to innovate. So you guys productize this and you guys are feeling like that's going to be a product that range between 360 kW rack or 70 kW per rack in density. That's going to be what will be the standard, and what you're anticipating in an AI data center.
Well, I think my opinion is we're about 2 years ahead of the IT that is actually going in, or what customers are deploying today. The two founders, they established a very green company. So they were looking at, what the carbon footprint is of a data center, what the power requirements are going to be, and how do we lower that PUE or get that efficiency down. And that's why they started looking at liquid cooling. And then with the immersion cooling and for our technology itself, like I said, what came out of that was, while we got these great efficiencies, all of a sudden there's heat reuse projects and other projects that we're kind of working on, not so much in the States, but a lot in Europe. They'll look at heat reuse in Scandinavian areas and stuff like that. So the hot water that's coming off the pipe that we're using off the heat exchangers, that's being used to, that waste heat is now being used to like heat a facility, heat a campus, go to a city. Was there a customer model first? No, I think it came out of, can we solve this issue or this problem? And then looking for, how that fits in. It just happened to fit in with what was kind of going on in the HPC world right now.
Makes sense. Okay, so that makes a lot more sense. So now you're seeing it. What are you seeing in this industry? What's the adoption rate of that you're seeing? And is it more from, like, what's the driver? Is it coming from the enterprise end user side more that are, because I've always felt like the enterprise end users are the ones that get to dictate what reliability standards are going to be in this industry and what efficiency standards are going to be in this industry. I know the operators try to do that, but they're not going to go out and create a product that they feel is the most reliable or the most energy efficient if the client won't make a purchasing decision in their favor. So typically the client or the enterprise end users who demands that these are things that the operators do. Do you see a lot of your business first, or the attention that you're getting? Is it really more with the G1K or the Global Fortune 1000, the largest enterprise end users, like the hyperscalers and the baby scalers, or is it the operators that are more inclined to try to adopt your technology?
So the hyperscalers is like a whole nother gorilla in itself.
Of course.
Right. And then there's the colocation providers that are both doing, wholesale colocation and retail colocation. And then there's the enterprise end users. And it's a combination of those. Let's put the hyperscalers to the side right now.
Sure.
And then let's look at the colocation providers. They have a different business model. So if their business model is power for contracted space, or just space and power, that's what their two main charging points are. If we're coming in and we're going to say, we're going to make it more dense and use less space, that doesn't necessarily fit that current model. The enterprise users, on the other hand, have always been looking for how to fit inside of that colocation provider. But some of the larger enterprise users also have their own buildings. So they might have their own campuses, say 26 or so, and they might have the current cooling that was set up for a 5 or 6 kVA. So they've got a chiller, they've got airside economizers, they've got block redundant systems, but now they're looking at doing some HPC modeling in there. We can come in 25% of that space, kind of build out a much more efficient way of deploying. So it's coming in slow waves with some of these. Most of our customers, because it's new, and they're looking at it, hey man, do you want to drop a hairdryer, into a bathtub? And then you're like, well, that's $150,000 hairdryer. And then if there's 50 of them, well, that's a few $1,000,000.
Yeah.
I'm not going to light that up all the way. So they come in, they're typically doing POCs. They're taking 1 or 2 pods down, and then they're looking at megawatt and 2 megawatt and 3 megawatt deployments as they build out. We have some providers out there for the IT that's going in there that make immersion ready servers. And then you have others that have immersion ready servers, but they're not your typical SKU that you could just go grab off or order from your typical Dell or HPE rep.
So let's talk about that, because one, I didn't think about it from that perspective. This is why I love DCAC. It's the first time where I really get to kind of put everyone together in rooms where it's an incredibly educational window throughout the years. Most conferences are, in my opinion, they don't have a purpose. They're just there for people to have an excuse to get out of the office and go party in another city. I'm hoping that people do that here, but I hope that they also get to listen and learn. One of the things that I love learning about is like, okay, so you have a capacity limitation to the tubs that you're using, probably. I mean, you're talking about 1 megawatt, 2 megawatt, 3 megawatt. That could be 2 racks. That 1 megawatt could be 2 racks.
Yeah.
Right. So, I mean, like, we're really talking about these applications where if you're putting these 2 racks in a tub, would they each individually be in their own tank? Is everything in their own tank? Or can you put multiple racks together and immerse them as one?
Yeah, so they like our XO product line. It has 2 tanks and 2 external CDUs, but it's built in high availability, so that one CDU could take over both tanks in case one goes down. And all of them are kind of modular in deployment. The main thing is to get to a water loop. Some of them will work with dry coolers and we can adapt it, but to be as efficient as possible, we're typically looking at a water loop. And we're looking at a set point of about 55 degrees Celsius, which is pretty warm, but it's absolutely within, as we just heard, within normal operating range for these servers. There are other product, which is an Evo, which is a smaller one. That actually has 2 CDUs actually put into the tank itself. So the CDUs are the heat exchangers and they're moving the fluid around. And with that, so we're looking at about 140 capacity, and it's a slightly smaller one. But again, it's modular in deployment. So they have quick connects for your water in, your water out, and your power.
So let's talk then about, now I understand how you lay these things into an immersion bath. You were talking about how there are groups that you are partnered with that already have the servers themselves. So you're agnostic. They could use an HP or a Dell or whatever they have that is the ability to go through immersion. But there's some other players that are maybe not as prevalently known that that's what they do too, right?
Right.
And you're saying you partner with those groups. So if people want the whole thing, they could get it as a service from you. So you could give them not just the mechanical or cooling permutation, but you give them the servers that fit inside of it as well.
So no, we don't sell the servers.
Okay, you don't.
But like somebody like Hypertech will sell our product with their servers.
Okay, so that's how it works.
Right.
How does that whole model work? Who's a Hypertech then?
Hypertech is a server maker out of Canada, and they make immersion ready servers native.
Okay, and they would probably be tasked with figuring out hey, I want those servers, but you're going to have to help me with the mechanical solution, and you're one of a couple groups, so they probably say, hey, we have, like, you're agnostic to HP, Dell, whatever, right? They're probably agnostic to a few things too. I'm sure you have some or do you have manufacturers reps that, like, are there other groups like them that you want to engage with in this podcast that'd be like, hey, I can sell those for you too?
So we don't sell directly, so we do like to engage with the MEPs.
Yeah, through the channel.
So with all of the data centers, because while they're all modular in design, they're all a little bit different. They're all a little bit customized. And typically we'll work with the MEPs and the infrastructure guys for that particular data center. We supply all the drawings, the diagrams, what they need, plus our engineering team works with them. They do all the installation, the setup, and set everything up. Bringing everything together like a total package, that would be fantastic, but it's sort of like this conference. It'd be nice if somebody brought everything together in this conference and was be able to package that up and sold it as a modular data center itself. And there's some, I think, that are working towards that, as I have met out in the during some of the networking events. But for us particularly, we're trying to supply all the tanks. We're trying to be agnostic. We want as many fluids out there as possible. We want as much IT gear out there as possible that's immersion ready. And then that starts to increase the adaption itself. Right now, you have a lot of direct-to-chip adaption because it actually fits in the current format of a current data center with the racks themselves. Most data centers are going to be looking for like a wet room, or wet data center hall, where you actually have the ability to tap into the chiller loop or line. So it's not something you would just put out right on the middle of a floor in a mixed use retail co-location facility, but more of a dedicated approach.
So let's talk about water and what the impact is to water to the topology or the footprint of a data center or a data hall now, right?
Mm-hmm.
I started in this industry where we weren't doing liquid cooling, we weren't doing immersion cooling, and maybe we were at HPC, very small fractional level, but it was all air cooled,
Yeah.
and you have a lower density per rack, so you could get away with those things. When you started shifting into what you're offering, you started seeing, there's a lot of differences in the footprint that we have. What are you seeing, some of the trends and what you're seeing? As an example, when I started, everything was on raised floor,
Mm-hmm.
right? 36-inch air plenums, and distribution of power would come from above, typically a whip or maybe a busway type of program. But now with what you guys are doing, I would imagine that, we made a huge shift as an industry to reduce costs as the price per megawatt became one of the driver factors. And we went slab on grade, right? So we were removing raised floors, and then we were removing the air plenums with them because we started getting to a higher density. So we started figuring out different ways to, cool. What are some of the trends and patterns that you're seeing your technology be able to play into, and will it shift some of those changes we made? Like I said, as an industry, many groups standardized on no raised floor. Everything they did was slab on grade. Racks would go down. Does your product, because of all the chill water piping and all the things you have, we don't want to put water above a rack. So if we're going to deliver water to a rack, we want to do it below the rack itself.
Correct.
Are you seeing changes back in the way that we build these deployments of data halls to where you can't deploy this product without having raised floor?
No. So I think there's two ways. What we see for greenfield builds is we're on slab, and the water's not coming from above; it's at the foot level.
Okay.
And as far as with raised floor on a brownfield build, I'm seeing the opposite. Since the floor's already raised, they're bringing the plumbing in underneath.
Okay.
So they're making use of we've got some very smart people out there on the engineering side,
Yeah.
and they're going to make use of what's available today. So it's been kind of an interesting mix between the two. Typically in the halls that they're going to do slabs because these are fairly heavy, especially with fluid in them. But manufacturing or going back or retrofitting some of the brownfields is fairly easy because they already have everything kind of in place. It's just a matter of whether they're going to do a rip and replace or start replacing that equipment along the way. We can use the existing HVAC chiller system and everything else, but now we're getting a much higher density out of it. So it really comes back down to that power question that we've been talking about all day yesterday, was how do we get enough power to the data centers to power up these cabinets at these densities?
I like it. What are some of the other things that you're seeing? It seems like you're making your way into the industry right now. You guys started in Spain.
Mm-hmm.
You came and you started a headquarters in Houston where you're manufacturing now.
Yeah, so that headquarters should be up in the next 60 days. So right now we've been manufacturing in Spain and shipping over. That way we can manufacture locally here in America.
Why Houston and not Virginia where you're at, as an example?
It's kind of central to everybody.
Oh, yeah.
It's central to our customers.
Sure.
There's plenty of good labor here and a great way for logistics.
When did you kind of get into the data center game? I know you were at Equinix and stuff like that, but when did your company get into the data center game? Were they originally doing this for data centers only, or was it for?
So the founders of the company, one of them had always been in the data center business. He used to run his own data center, and that he was kind of contemplating going back and forth with, there's got to be a better way to run this. He sold that data center and then had been working on this technology, and that's Danny Pope and Paul. Those are the two founders of the company.
Where do they live?
They live in Barcelona.
Okay. And then what's the presence that you guys have? You're one of many, I'm sure, that are in Texas, but are in the company in the United States. But where are you taking your guys' strategic initiative? Are you trying to grow primarily in Texas? Are you chasing enterprise only? Or are you trying to get to Northern Virginia and all the other NFL cities? What is the plan and the strategy to deploy this, and then how can we help?
Yeah. So we're heavy in Europe. We're in Asia Pac right now too. And we have our R&D hardware and wet labs in Europe. We've got new R&D wet and dry labs going up in Houston. And we have people deployed in offices for Denver, the West Coast, Seattle, Virginia, New York, and New Jersey, and Houston. So we're pretty well covered on the United States right now and are going to be hiring. What we are looking for is additional people to understand the technology, start adapting to technology, because it's scary at first.
Dude, these are new. It's bloody going through the wall when you're the most advanced form or cutting edge of technology. What we do, I believe, like you said it's interesting how you said you guys are about 2 years ahead of your time. I would say that I would have thought that until, listening to Wade and stuff like that. But I think that you're 2 quarters ahead of your time. I think that what you're going to see is the demand for a product that you have the ability to fill, or the solution that your product can provide, is going to be much more prevalent before the middle of next year.
Most of the customer interest right now is coming in saying, I need to build out 1,000 GPU cluster. Here's my space and requirements, constraints. How can you do it? In a typical data center fashion, it would be of a certain size in order to cool that, because they work on CAD-B equivalents. And then in ours, we can probably break that down to about 25% of the time. Most of the thing is you're going to see mixed use spaces, because some of your switchgear doesn't require that high kVA or density. Some of your other servers that don't. But when it comes down to these GPUs that we're looking at right now, and these GPU clusters that customers are trying to deploy, we've seen a lot of ask specifically just around that.
So is your product, is it available only on a CapEx model? People have to buy it, or do you guys have the OpEx model where they can lease it from you as a service? Or
right now it's a CapEx model.
Okay, I got it. So talk to me about what the plan is, and what's Nirvana look like? Who is the ideal client that you have for that product? And I know that you have a wide aperture. You could go between 7 and 300. Was it 360 kW per rack, you said?
Yeah, up to about 360 kW. And if we wanted to do high availability, that would be like if we turned everything on. If we did high availability with 2 tanks, we can do 0.5 megawatt. So that really breaks it down. But you're looking at very dense, because you're looking at using maybe 100 RUs between the two. And those come in like 19 and 21 inch. Even the RU. Let's talk about that for a second. We don't even need the chassis. So what if you got rid of the chassis? Because the chassis are just there to hold the fans and everything like that. But then you can just start stacking boards and chips together. I mean, there's other things that you can take it further. You just need the adoption to start increasing for what those particular applications are. And we're seeing a lot of that in this AI race with the H100s, the H200s, and now the B200s.
So that's what I'm asking. I'm trying to figure out what the sweet spot is, because it seems like everything in this space right now is complicated for the first few years. Getting our minds wrapped around some new construct of energy or cooling it just takes a little time, right? Because we originally built data centers and design enterprise data centers, even for financial institutions at a different tier level. And then as soon as we figured that shit out, then all of a sudden we had to build for cloud. And then all of a sudden we got that all figured out, thought we had it on lockdown on an efficiency perspective. And the next thing you know, we're building AI. And AI is building a bigger footprint. They're building campuses or, gigawatt campuses now, right? So how does your product, is it designed with a price point of efficiency where you get a better price at scale, in volume? Or one of the things that's slowing down AI is the function of economics, right? It's not, technology is always ahead of everything else, but human biology, it doesn't iterate as quickly, and finance needs a little bit of time to make sure they figure out how to pencil it out, right?
Right.
So my thing is how, what's the sweet spot? Is it 1 meg, 2 megs, 3 megs? Because after that, then that's what you would spend a lot of money into for Ferraris. But, some things you just have F-150s that you need to cool as well, right? You're going to put a nice place for those really expensive units. But sometimes you need other ones. Is there like a small, medium, and large product that you have in terms of density? I mean, have you productized this, or is it just based on its capabilities?
It's based on its capabilities. Some of the data center approaches that we've seen today have all been where they would dedicate a room if they were going to do immersion or any type of liquid cooling. A lot of them don't want to have any sort of fluids on the actual data center floor, or they're going to separate it. So we're seeing suites or data halls being built dedicated for immersion, or we're seeing
that makes more sense.
Smaller data centers or larger ones just converted all the way to immersion. But it's a fine mix. So let's say on an example where you've got one data center with 3 different data halls. Your first 2 might be, a lower capacity, and you have immersion in the final data hall. It's going to be a mix. It's what's taking what's available or what the customer problem is that you're trying to solve and kind of figuring that out. And it's different for enterprises as than it is for hyperscalers. The hyperscalers is a whole different ballgame as the way they build and the way they scale out, it's as modular as they can and as big as they can. But their testing and their approach to it is very, very specific for what their need is. So it's the dollars and cents that add up for that one. It's the economies. But when we look at economies of scale, small percentages for those guys are huge amounts of dollars when you think of it. And even for your enterprise approach, so the enterprise guys, they go over to co-location providers because you know what? They don't run a data center for a living. They run their application. You're seeing a lot of applications built as sort of that are going to be built on top of AI. So an AI as a service type of application. You've got your application guys who just want the servers to function, and you got the infrastructure guys who are keeping the servers up. Doesn't necessarily mean that they are all working together. The application guys maybe never set foot in a data center. They don't care, but everything's got to be running. And at the end, for that enterprise, they're offering a product or a service that has to have X amount of nines of reliability. So they want the best bang for their buck and the best dollar. So if I'm trying to increase my own margins within that, and I can lower my overall cost for what that capacity is or get more out of it, because most servers are kind of locked down. We haven't even talked about the ability to start overclocking things yet, because we're at our limitations with air cooling today.
So there's over what?
Overclocking.
What is that?
Like if you mess with the voltage and the regulation of a chip and you actually put it in kind of like a boost mode. Most servers will lock it down because of the fact of it voids a warranty. Yep. But on workstations, you'll see that, and in some of our labs, like we're overclocking them just to get as much heat as possible out of a single RU or a single KW.
You're redlining these things to see where the breakpoint is. Awesome. So where are you seeing, what is the pattern that you're seeing? And for you guys to take that product and introduce it, you feel like it could be a mainstream application that's broadly used amongst AI, right? Is there a maximum capacity limitation on a data hole, like 10 megs? I don't know.
No.
Okay, nothing.
No. Some of the larger ones that we're working on for hyperscalers are awfully big.
Okay, and they're looking to standardize on their entire production environment of AI with that product? Or would it be for the highest applications or something?
I think it would be for the highest applications. It's not necessarily that they share the exact application that they're working on. And it depends on where they're working. Like I said, if it's a European deployment, a lot of them are looking at doing heat reuse, trying to maximize what the ambient temperature is in that region, anything to bring down that overall lower cost and be more green and more efficient.
All right. So the whole genesis behind this product was efficiency, right?
Yes. The whole genesis in the beginning was efficiency but what we've come to find out is that there's a definite need for on the high performance computing side.
And what did you find? What was that need? What did it look like? What was the pattern of the trends that you guys saw where you said, hey, this is a product that has these capabilities. We need to go introduce it to this market that has these demands and let them know that they're capable of achieving these other.
Yeah, nobody was trying to run 100 kVA 3 years ago.
Okay.
When we're developing the product. Yeah. And right now our smallest pod runs about 140 kVA.
140 is your smallest?
Yeah.
Oh, I thought 70 was the smallest. No?
No.
Okay.
140 is the smallest.
Is there a lot of people running at that right now?
No.
Okay. I mean, which vertical of industry? I know it's HPC typically. In my experience, it's been higher education or oil and gas has been HPC.
Mm-hmm.
Is that about the right vertical that you're getting into?
It is. And then there's some government. So there's a couple of labs that are been working with some of our stuff, just trying to push it there. And then you have there's a bunch of value-added like resellers that are packaging their applications with their servers with immersion technology. And there's probably about 5 or 6 companies in our field right now that have tanks that are offering immersion. So they're testing out all the different ones and comparing them. Luckily, we seem to be up at the top.
Nice. What is the pattern? What are you predicting? What's your company seeing the trends for the future with density? I mean, like we would have never a year ago we wouldn't have been on a mainstream platform talking about how we're going to get to 300 plus kW per rack, right?
Mm-hmm.
Today we're talking about how you guys have the capability to do that, but it's probably going to hover closer to 100 kW per rack or 140 kVA. So my thing is how much higher in density do you anticipate this growing?
So when we talk about density, right, especially when it comes to immersion cooling, that's taking the capability, to its max by using the coldest water possible for our chiller loop, right? Well, what if we don't use a chiller loop? So what if we are just running at 50 kVA and we don't have a chiller? You don't need one. So what if you're taking advantage of some of the infrastructure that's existing today? You don't need to run them at their max performance, and you're still getting all that efficiency out of it.
What all are the offsetting benefits of having this type of cooling permutation? I mean, obviously containment goes away. There's certain things you do, but what are some of you're competing against traditional containment models? Is that what you're doing?
Yeah. So right now in colocation, you've got hot and cold aisle containment, you got rear door heat exchangers, you've got direct to chip, you've got in between the cabinets. I forget what that one's called. And they're actually building shells out inside of data centers for particular customers. Those are the technologies that you're kind of competing against. In that case, some of those customers need more actual footprint than they do for specific density. But in others, it's where they're trying to, you ever go into a data center cage and you see a couple of, servers populated and the rest is all blanking plates. Well, the reason why was because, they don't have enough cooling for that. So they have to spread out that load. So you might have 5 cabinets in what would have been a 37 cabinet space. I'm seeing some changes over there from the density and from the deployment models, but you also have to figure out, and it needs to work with whatever that business model is for that client. So those are the kind of differences that I'm seeing out there right now.
Very nice. Well, tell us anything else you want us to know about your product and your business. I mean, this has been really informative, but I mean, you go an inch wide and a mile deep on the mechanical solution, and what you're talking about is what Wade was talking about. We were listening to Wade together before we came in here, where densities are just going to continuously go up. The ability to solve for it at a larger volume and scale is going to be the challenge. The technology application exists to do it, but at what volume and scale can you guys get to with that? Can you do 100 megawatts at that same sort of, can you do 100 megawatts of 100 kW per rack?
Yes.
Okay. And have you?
No.
Okay. But the capacity to do that is there, you're saying?
Yes, the capacity to do that is there. Our manufacturing capacity to do that is there. It's just the IT hardware that's starting to keep up with it. So what we need is more immersion ready servers to go into the tanks, and also immersion ready switches. So while our tanks have dry areas, the switches don't necessarily need that. They don't need immersion capability. They're not that hot, but some of the newer switches are. So maybe testing and certification by the OEMs for immersion ready servers. So that is a SKU that you could order.
How long can immersion ready servers, what's the longevity of one of those in this type of application?
So it's actually higher. So that's kind of really cool. In data centers themselves, like the biggest problem that you have is dust and cardboard. They'd always find people for having cardboard in their cages. With immersion ready, it's a sealed tank, so it's got a lid, so it's closed, it's secure. Then that's where there's implications for it's not just a high density product, but how about manufacturing facilities that are very dirty as far as atmospheric conditions? You're able to deploy one of these there on its own by itself. You can deploy it to hospitals. You can deploy it to, let's say, rural mining areas,
Okay.
Where we're taking a cargo container and filling them with a bunch of pods and sending that over. It could be a standalone.
I like this.
Yeah.
I got you. Well, listen, man. I mean, we got DCAC live going on. I know there's still a whole bunch of badass speakers going out there. I want to bring this one home, but I want to give you the opportunity to mention anything that maybe we didn't cover. Or it's a lot to unpack, but it's a very, very deep and intense topic that it's going to take time for us to deconstruct and unpeel. Don't you agree?
I absolutely agree. It is going to take time. There's a lot of opportunities out there right now. There's a lot of opportunities.
Next year, you guys should come and sponsor, and you should bring one of your tanks.
Yeah, that's kind of the coolest part, seeing one of our tanks in person.
Yeah,
everybody wants to kind of
let people see it.
Yeah.
But what else do you want people to know before we pivot and go back out there to enjoy the conference?
That's it. It's a great conference. If you haven't been here, please, come down, come check it out. And it's been awesome so far.
Tobias, thank you so much. How can people reach you, Tobias? There are people listening live, but people are going to listen to this one later. How do they find you? Is it on your LinkedIn?
Yeah, I'm on LinkedIn, Tobias Quaranta.
You got to spell that last name.
Quaranta. You'll find me.
There's not a
lot of me out there. So.
Yeah, well, listen, man, this has been awesome. Is this your first DCAC?
Yes, it is.
All right, well, hopefully it won't be the first of many, not your last. So, and I hope to continue to scratch the pain on this topic as we go. This is something that if we don't solve for this, it stunts the whole growth of the industry. So we have to figure this stuff out. So thank you for being a part of this. Thank you for coming to the conference, and thank you for sharing what Submer does with all of us.
Yeah, I appreciate it. Thanks.
All right, buddy.